Righty. Hey, good evening. Good evening. Susan, hello, hello, hello. How's it going? How's everybody doing? I hope everybody's doing good. All right. Let me switch to my face cam. Alrighty. Good stuff. You good? Good, Yusuf? All right. I owe you a question, right? Right, Susan? I think I owe you a question. So, I saw your couple emails there. Just give me 1 second, though. That's about midnight in England, yeah. All right. Oh, we out here doing math? We are out here doing math and other things. mm, possibly other things. Susan, you doing all right? Good, good. I'm doing good, Susan. I'm doing good. I've seen your emails there, and yeah, I know I owe you a question for sure. Like I know you want help with that one question on 8-1. That's probably bothering you. Natty, hello. How's it going? How we doing today? You're Gucci, very good. You're very happy the hashtag started football again? Me too. Me too. Trust me, me too. I'm happy hashtag is back in action. Non-league football needs to start again. It should have started a while ago, but well, here we are, I suppose, Yusuf, to be fair. Oh my gosh, so much to write in. Why does this require so much typing? Oh my gosh. I need to like not type so much. Oh my lord. Significance. Yeah. Wish I could do things. Oh my gosh. Oh man, look at all this stuff I gotta do. Like I'm typing up stuff for today's class, and it's just like, oh man, so much to do. James Fuse Cryptic. I changed my Twitch. Good to see. Hey, Fuse. I hope you're doing good, my friend, aka Mason. I'll just call you Mason. It's just easier that way. But I hope you're doing good, my friend. Are you doing well? I hope things have been hope things have been good on your end. So things have been you doing well? Wonderful. What you been up to? You gotta let me know. You gotta tell me what you've been up to, my friend. It's been a little bit of time, so hopefully you've been chilling, having a nice time, or if you've been busy doing other things, it's totally understandable. I just have been playing Cold War. Nothing wrong playing some Cold War, let me tell you. I've been playing a lot of Cold War too, to be honest. I'm only Prestige 2, okay, mind you, I haven't been as hardcore because I just got into the game. But I heard that there's a new COD game coming out soon. That's what I heard. So, hopefully that one is another. Apparently, Prestige 2 as well. Okay, yeah. I took advantage of that long 2 XP weekend. I got all my 100 tiers though, so I was pretty happy about that. My God. I don't know what your favorite gun is, but my favorite gun is the, I love submachine guns. They're really fun to work. They're really fun to play with. Oh, I didn't want to pick that one. Why did I pick that one? That wasn't the right one. There we go. Use the AUG and the MP5. The AUG is really good. It's just that short fire burst you have to really get used to by clicking on the on your mouse there. The MP5 is always fun. That's a super fun gun. I love that gun. Super, super fun. 100% agree with you. 100% agree. Alright, that should take care of that part there. Oh, perfect. Okay. Now I got things clarified and ended off. Yeah. Alright. Alright, here we go. Ladies and gentlemen, thank you very much for coming on here today. Thank you so very much. I really, really appreciate it. We're going to get started here in just a couple of minutes, okay? We'll get started with some new stuff, for sure. So, we'll certainly get going here, and we'll do some mathematics, for sure. Absolutely. Just setting up everything here. It's taking me a while. My math lab is up and running, by the way, ladies and gentlemen. If you weren't aware already, it is working. So that's been very, very good. So you should have a chance to do your test there by the end of the day today. So don't forget about that. Alright, let me grab the book here. That is not what... Okay. Okay. For some reason that's taken some time. Finally got the exam done, Mazdy? Very good. Wonderful. That's good to hear. Glad you're able to finish that off without too much trouble. All right. You got your exam soon? What's your exams on, my friend? What exams are you doing? Okay. That's weird. Just English, maths, and PE. Oh! Very nice. Prime Gerard from a 5K pack. You can't go wrong with that. Though I hope you're not giving the money over to EA. Jeez, indeed. Don't give money to EA, please. April Fools. Oh, it is. There you go. I'll allow that. I'll allow that. I'll allow that. That's right, it's April 1st over in England now. Oh no. My book is... Pearson has decided to die for about 10-15 minutes. I guess we'll have to wait a little bit there. Alright, we'll just kind of have to run with it. April Fool's is tomorrow. This is true. This is true. You got a Pele from a bronze pack? Yeah. Yeah, sure you did. Sure you got a Pele in a bronze pack, and I got every team of the year card, you know, in every... I got one team of the year card in every pack I opened. I don't even own the game. Oh my gosh. Look, 99 Mbappe. Yeah. Oh man. All right. Okay. All right, ladies and gentlemen, let's go ahead and get started. Let's do this, and hopefully there'll be some more people that join us in and along the way. All right. So, but we gotta get started nonetheless, irrespective of what I think. Um. All right. Okay, let's get started today. Welcome back to Wednesday, end of the week time today. So today we're going to be going over a new chapter here in chapter 10. Diana, hello and good evening, afternoon / evening to you. Welcome to the very beginning of class. We just came right at the right time. Perfect. Um, uh, well, so I want to thank everybody coming out here to the stream once again. We're going to go over a new chapter here, 10. We're going to go over chapter 10 here. We're going to hopefully get over these next couple of sections here in chapter 10. All right, chapter 10 here, at least for what we're going to be starting with, is going to be a pretty big setup for the next 3 chapters, okay? Because all of it's going to revolve around the same idea. All right, we're just going to be doing it in different ways, okay? So a lot of different... pretty much like doing the same thing here. We'll have different scenarios, but we're pretty much going to be doing kind of testing here in various ways. All right. Yes, you are in the first day in April. I'm still in the 31st of March, my dude. 31st of March means I still gotta run with chapter 10. All right. Um. Okay. Don't forget here, everybody who that the test here is due at 11:59 p.m. Okay, do not forget that 11:59 p.m. All right, so you make sure to have everything submitted, all the homework and tests and stuff. Make sure you have that submitted if you don't have that submitted and saved by before 11:59, so it counts. Okay, so if you save it after that point in time, it won't count, and then there will be incredible sadness, and then you will regret many life choices up until that point. Um, so that is something that you want to do here after class. I've noticed here on my math lab that things are looks like they're having just a small issue that will take about half an hour to fix. So hopefully that will clear itself up. In the meantime, however, I can always make it work around that. All right. So today we're going to be talking about hypothesis testing, okay? Hypothesis testing is what's next on the docket here in sections 10.1 and 10.2. And this is going to be incredibly important for things we're going to see in chapters 10, 11, and 12. So again, remember here, chapters 10, 11, and 12 are the last 3 chapters here in the textbook, and they all revolve around this idea of hypothesis testing. So in the first section here, we're going to talk about the basics of hypothesis testing and what the purpose is, you know, a lot of the notation here that we're going to be looking at here. And then we'll be looking at one application of hypothesis testing, using our good friend proportions like we've been using here in the past couple of classes. So we're going to be looking at that here today and figuring out how to approach these testing kind of problems. So some of it's going to involve calculator use. Some of it's going to be, again, setting up the problem appropriately here. There's a few steps involved here, so I'm going to break it down here today. We're going to go over it a little slowly here because there's kind of a, at first it looks like there's a lot of information to take in, but once we break it down one piece at a time here for these hypothesis testings, you'll notice that there's a similar pattern here, just with a few changes here and there in order to get it down correctly. All right, so let's go to the big board here. All right, so going to the big board here, let's take a look at what we see. All right, so what we see here specifically is, let's take a look at question number 1 here from our handout. Now, the first thing we need to talk about is, what is the null hypothesis? So this is something that I'm going to refer to quite a bit. What is the null hypothesis? Now, the notation here for the null hypothesis, I'm actually going to make this a tad bit bigger. I'm going to make some distinctions here. The null hypothesis here is going to be notation as H0. So sometimes you'll hear me say the null hypothesis. Sometimes you'll hear me say H0. In either case here, it is referencing the null hypothesis. Now, what is the null hypothesis as a definition? The null hypothesis here is going to be what I like to call the base case or the baseline you are testing against. So in every single one of these hypothesis testing problems, we're going to have a baseline or base case that we're going to be working with here. All right. And we want to be able to determine what that is in comparison to what maybe the claim is going to be made by the researcher, for example. Okay, so that's the null hypothesis here. Now, the claim made by the researcher here, as you can see, is what we call the alternate hypothesis, or the notation here is H1. All right, so with H1 here, that's going to be the alternate hypothesis. Again, this is the basic claim here on the researcher. Now, one of the things that I guess I should say here in this case is the claim made by the researcher in question given in comparison to the null hypothesis. This is one of those things that you have to be a little bit careful about. So I'll put, this is something that we talked about before back in chapter 8. Okay, actually, I should say even back in chapter 6, is that once again here, wording is very important. So again, read carefully. All right, so be sure this is very important because of how we want to actually approach the alternate hypothesis and exactly what kind of comparison we're going to make here. So it is going to be a pretty big deal here. I'm going to read this carefully here. It's definitely going to be a thing. All right. Okay, now why is that going to be a thing? Well, let's take a look here. What we're going to have is we're going to have 3 types of alternate hypotheses for the most part about what we want to be looking at here in these type of problems. So we have what's called, what are the left tail, right tail, and two-tailed alternate hypotheses. So here's the general template of what a lot of these problems for this, quote unquote hypothesis testing is going to look like. All right, we're going to have a null hypothesis here. Say we have some parameter is equal to some value. So you could say x is equal to 50, or something like that. Okay, it could be whatever you want, but let's say it was x equal to 50. Now, there could be a claim made by the researcher for the alternate hypothesis here, and you could say, well, we could have one of these 3 cases. The researcher could say, oh, I claim it's going to be that whatever parameter is going to be less than 50. So if we say it's less than, that's going to consist of a left tail test. Okay, so that'll be a left tail alternate hypothesis. A right tail test or a right tail alternate hypothesis is if we say, oh, well, the claim made by the researcher says, oh, I think that that parameter is going to be bigger than 50. Okay, fine. That could definitely be a thing. Or we could even have a two-tail case where we say, okay, well, that parameter could be maybe not equal to 50. So you say, okay, I think it's not equal to 50. Say that's fair. All right, fine. No problem. Good stuff. All right. So this is I'm gonna give a little time for you guys to write this part down here. This part, actually, I should say this whole first page here. If you don't have this in your notes, it's gonna be a rough time. So let me give you a few, give you like 30 seconds here. While you guys are doing that, I will enact my ulterior motive here really quickly. I'll go grab a drink for myself. Hang on, I'll be right back. So yeah, my math lab's having issues again. They're having an issue. They said it'll take about half an hour to fix. So if you're having issues there, wait about half an hour or so. Um, I just saw the message on their website. They know that they're having issues there. Give it about half an hour, Demar. Yeah, no problem. It's all good, man. Check again. Yeah, it's still gonna have issues. Okay, that's fine. Give it about half an hour. Hopefully they'll fix it by then. All right, good stuff. Okay. Okay. So hopefully you have that written down here because we're going to be using this here in several problems. Well, lots of problems actually. So kind of like the basis here. Now, let's talk about probably besides this question here, number 3, which is going to be a setup for a lot of things that we're going to be doing here in this course. I want to look at number 4, which is probably one of the most important questions here in this entire chapter. Okay, so you're probably saying, well, why is this one of the most important things in this entire chapter here? Well, the reason is because of what we want to find here at the end of the day. Okay, so you're like saying, well, what's all this stuff for? Okay, fine. What are the answers to these questions that we're trying to find here? So that's what I've kind of acknowledged here in number 4. What are some conclusions we can state when doing hypothesis testing? And this is the most interesting part here. The most interesting part is we only make 2 conclusions, i.e., there are only 2 final answers. There are only 2 final answers here for hypothesis testing. Okay, so when it comes down to it, we're going to basically make 2 final answers, and that's it. So the first final answer is that we accept the null hypothesis and reject the alternate hypothesis. Sometimes, so you'll see that there. Sometimes you'll see it in other cases. This will be written as something slightly a bit different. So if you do see this in the homework or the textbook here, this can also be written like this. I'll just say it says do not reject the H0. I'll put H0 just as a paraphrase here. So do not reject the null hypothesis here. So if you do see that do not reject, that's the same thing as saying accept the null hypothesis and reject the alternate hypothesis. All right. I'm not a big fan of that wording here because it makes it more confusing. But if you do see that in the homework or in the book, that's exactly what they're referring to in that case. Okay. The second conclusion here that we can make, and again, the second possible final answer here for these type of hypothesis testings, is we reject the null hypothesis and accept the alternate hypothesis. Okay, so it is going to come down to pretty much one of these 2 conclusions. So that's really nice for us here, is that, okay, at the end of the day, you're like, okay, fine. What's my final answer? Okay, now I get one of those two conclusions. One of those two guys is my final answer. So we've boiled down all these problems here that we're going to look at down to two final answers. That's it. All right. So I want to make this as simple as possible. I said, okay, fine. If you're just going to give it to us like that, all right, we'll just run with it and we'll be cool with that. Easy peasy, lemon squeezy. All right. Next. By the way, are there any questions, by the way? Any questions? Any questions so far? No questions yet? Okay. I know you guys are like, this is all words. This is no math yet. I'm like, yeah, I know. I want to be sure that at least that the concept hasn't gone over your head yet. Yet. Word is yet. All right. Let's take a look here at number 5. Now, a couple of things that we're going to be looking at here are, well, actually, we'll be looking at type 1 or type 2 errors here. Now, let's take a look at what type 1, type 2 errors are here. In hypothesis testing, a type 1 error is that if, let's say, in reality, the null hypothesis is true, but we rejected it in hypothesis testing, then that's what we call a type 1 error, where reality and testing don't meet for some reason. For some reason, the numbers worked out very differently than what reality is actually telling you. So um, that can happen, okay, where there's a disconnect there. You try it with numbers and it tells you something different than what reality is telling you. And the same thing can be true for a type 2 error, where basically the alternate hypothesis is true in reality, but you rejected it here in your hypothesis testing. So same exact thing. Somehow the numbers didn't work out where your claim was true, but okay, so that's a type 2 error of some kind. Just like anything else, any type of testing here, there is a little bit of leeway in terms of how much error that you can technically give. Okay, we're going to look at exactly how much error we can actually give once we do some of this process stuff here. All right. Critical value. What's a critical value? Now, we've talked about critical values before. All right, we talked about critical values in confidence intervals, about how to associate them with a particular confidence level. All right, that's also going to be used here in some capacity. We may or may not use this entirely. Okay, so I basically put in here, we'll be using it in comparison in determining a conclusion with some hypothesis testing. When the time is right, we'll go over it where it's necessary, depending on the section that we cover. Okay, so once we get to that portion there, critical values are going to be important. I'll talk about it. I won't talk about it too much in detail for the next section here, but I will talk about it in possibly maybe one or two other sections here. So just to let you know here, um, critical values will be a thing here, but there are things that we could use the calculator for to find particular values. So that's what we're going to do. All right. Now, let's look at number 7. Number 7 says, what is a significance level? Okay, a significance level, first of all, the notation here is going to be alpha. Okay, so this alpha here is going to be a significance level. And the level of significance or significance level, whichever way you want to call it here, is equivalent to the probability of making a type 1 error. So the probability of making a type 1 error is going to be the level of significance. All right, and we're going to be using this level of significance and very importantly in order to make our proper conclusion here at the end of the day. So we'll see. We'll see exactly how we can we'll be given the level of significance here in every question. So I'm going to go ahead and make a note of that. Note, you don't need to find this level of significance. You'll be given the level of significance. in the question. So there we go. You got it. All right. Good stuff. Okay. All right. So before we move forward here, are there any questions about these basics here? So I know that this is pretty much at this point pretty abstract, okay? But we're gonna do some actual numerical stuff now, um, with a little bit of a setup. But any questions about that? Because this is essentially all these basics here is going to be section 10.1. Okay. Okay. I'm sure you guys are working on writing notes, so totally understandable. There's a lot in here, I won't lie. Okay. All right, let's move forward here. All right. Now, no? All right. Okay, so we're now going to transition, and that took me all of 20 minutes. Okay, so 23 minutes to actually get through section 10.1. All right, so now let's get to the meat and potatoes of what we're going to be doing here for the remainder of the time here today. And we're going to be talking about section 10.2. Let's at least get a good footing here about how to do some of this hypothesis testing. All right, so let's go to question number 8 here. Question 8: what assumptions must we make to do a hypothesis test for a population proportion? All right. So there's three assumptions that we can make. One of these should look fairly familiar. First of all, our sample is a simple random sample or a completely randomized sample. That's exactly what we should have here. Secondly, is the probably the same conclusion here for proportions that we've looked at here in two previous sections already, is that NP times 1 minus P has to be bigger than or equal to 10, so you have a large enough sample size to make a proper conclusion, and that the sampled values are independent of each other, so essentially, if you say ask a question, one person's answer doesn't affect another person's answer. All right, so they have to be independent. Fine. It is what it is. Okay. All right, so what we're going to be focusing on here is we're going to focus on the p-value method here today about how to come up with the conclusion here. Now, due to the fact that my math lab is down here for whatever reason, I'll just type out an example here, and then we're going to go over these steps here about how to go ahead and solve for this. Probably should. All right. Okay. So, how do we perform a hypothesis test using the p-value method for a population proportion? All right, step one, we have to determine the null and alternate hypotheses. Now, I'm going to add a little bit more to this first step here. So, uh, mind you, this is not fully complete here yet. We have to determine what these guys are. All right. So first and foremost here, let's state the null hypothesis here. Now, that's actually let me do that. I'm talking a lot here, but I need to actually type out a so. Okay, there we go. Yep. I'm gonna type this out here and no, no, okay. All right, so the example that we're gonna do here in this case is, because I don't have the book available, sadly. The example here we're gonna do is going to be this is gonna be number 21. All right. Number 21 on page, well, number 21 in section 10.2. I don't know what the page is, unfortunately. But I'll type it out here. So it says in 1994, 52% of parents' children in high school felt it was a serious enough problem that high school students were not being taught enough math and science. Okay, a recent survey found that 256 out of 800 parents with children in high school felt it was a serious problem that kids were not being taught enough math and science. Do parents feel differently today than they did in 1994? Okay. All right, so let's at least go with that and see. Can't spell today, but that's okay. Sorry about that, folks. Okay, so let's go with this question here, and we'll see exactly if this works out appropriately. Let's take a gander. All right, so we're going to go through the steps here carefully, one step at a time, and we're going to see exactly how we can determine our hypotheses and all of the numbers also included here as well. Okay, so first step here, let's go to step number 1. All right. Actually, let me put this on the here. Okay. This is one of those times where I would say I would like a board over so a whiteboard is actually much more convenient here. An actual physical whiteboard. Could do a lot more on a physical whiteboard, in all honesty. For these cases anyway. Okay. So step 1 here is to determine the null and alternate hypotheses. Now, what is very important here for the null and alternate hypothesis is how we're actually going to define both of these guys. All right, first of all, we need a baseline here. We need a base case for our null hypothesis. So for our null hypothesis here, which is specifically H0, whenever I can. So our null hypothesis here is going to be specifically, this is going to be very specific. This is going to be P here is equal to the population proportion. So whatever our population proportion is, that's what our base case is going to be. That's our baseline, all right? So let's take a look here in step number 1 for this problem here. If that's true, right, and we want to find our null hypothesis here, H0, all right? According to our question here, what is the null hypothesis? What is going to be what's our population proportion here? Our population proportion here. What is our P going to be equal to here for our problem according to what we see here on the screen? Okay, that is correct. Very good, Natty. That's right. It is 52%. So we're going to make a comparison here. It says, okay, let's compare, yesteryear to today, well, in the yesteryear, it said 52% said, yeah, I think it's a problem. Like, okay, fine. That's fair. So let's go ahead and put 0.52 here. That's correct. All right. So far, so good. All right. All right, let's go back up here for just a second. Way past where I needed to go. All right. Okay. Now, the next part here, and this is the more important part here, is what about the alternate hypothesis here? Okay, so what if I wanted to determine, say, hey, what is the alternate hypothesis here? Well, this is the part where we have to read this very carefully, okay? But it's dependent on what the population proportion is. So either P is going to be less than the population proportion. So this is going to be, again, a left tail case, all right? Or we could have P is bigger than the population proportion, in which case that's a right tail case. Or we could have this here. Let me insert that. Where is that? There. So, or P is not equal to the population proportion, which in this case, we have here a two-tail case. All right, so we could have one of these three situations that could happen here if we're the alternate hypothesis. So let's take a look at the question here. If this is what can happen here, depending on, now of course this is dependent on the wording here, okay? So you got to be careful about the wording here. Got to be very careful. So take a look at the wording here. What kind of alternate hypothesis do we have here? What's our alternate hypothesis here? What is our alternate hypothesis here for this problem? What is the alternate hypothesis here for this problem? Not 256. A left tail, 0.32? I don't think that makes much sense here. Remember, it has to follow one of these three things. One of these three is true for this problem. So either P is less than, P is bigger than, or P is not equal to. All right? One of those three is true. Say left tail, right tail, two tail. Now, let's talk about the wording here in this problem. Maybe you're not sure. This is fine. Let's see what the researcher is trying to claim here, because that is the big crux here. What is the researcher trying to claim? Take a look at the last sentence that it asks. Take a look at the last sentence. Do parents feel differently today than they did in 1994? So do parents feel differently today than they did in 1994? So would that be bigger than, would that be less than, or would that be not equal to? Would that be bigger than, would that be less than, or would that be not equal to? What do you guys think? does differently mean? Does differently mean less than? Does differently mean bigger than? Or does differently mean not equal to? See a lot of different interpretations here. I would like something a little bit more concrete. Okay. All right, so if you say you're different, right, it doesn't mean you're bigger than, because it doesn't say, like, say it's bigger than would mean like it's more, right? Less than would mean it's less. But if you're different, then that means it's just not equal to that at the end of the day. So in this case here, the claim made by the researcher here means that P, that's okay. That's why I'm stressing the wording so hard here, Susan, because it's tricky when you're not. If you gotta look at it carefully here, wording here can be pretty tricky. So if we're gonna get one of the three cases, we just want to be able to pick out the correct case here. So let's say P is not equal to 0.52. Now I do want to point out one thing here, by the way. I'm gonna make a note here for this example specifically. So note here. You will have the same number in both H0 and H1. All right. So you will have 0.52 here and you'll have 0.52 here. All right. These numbers are not going to change. Okay. If this was like, let's say the proportion was 0.37, then this would be 0.37 down here. Okay. So that you're not going to have two different numbers in two different places here for the null and alternate hypotheses. All right, so please be careful about that. Make sure you don't make that mistake, okay? That is not too fun to be. Common things people try and put the different numbers, really not necessary. So I put the note there, so be sure that you guys are taken care of. Okay, fine. All right. Any questions before we move forward here? Any questions? So in what case would it be bigger than or less than? So good question here, Mazdy. So instead, what it would be written here is like you could say does the researcher, or say do parents instead of do parents feel differently, it says do parents do parents feel like it's less than what it was in 1994. So you could say do parents feel it is less than 1994. Okay, or do parents feel it is more than 1994, for example? Okay, just as, so you'd have less than, it will tell you, it's like, it's basically going to tell you, just have to read sometimes between the lines here. You just have to sometimes read it carefully and say, all right, it's going to be one of these three cases. It's going to say more than in some capacity, it's going to say less than in some capacity, or it's going to say it's different or not equal to in some capacity. So just be on the lookout for those wordings there for those same inequalities like you have been doing in the past, okay? Yeah, we'll do another example after this one as well. So we'll look at something a little bit different. But again, setting it up here is important. So, all right. Okay, so oh yeah, I'll add that in a second. All right, so we have to determine the type of test. What type of test do we have here? What type of test do we have? So in step 2, that's what we want to do. We want to determine the type of test, left, right, or two-tail. The answer is definitely two-tail. That's correct. So there is a reason why I will ask you in this case here, the type of test. One of the important things that we want to actually do is organize our data appropriately. This is also true in the calculator. So knowing what type of test that we're working with is going to be important. All right, so I put it as a separate step so that way you do not forget. Okay, so we want to cover our bases as much as possible because we just want to go through this process once, and we don't really want to come back and do it again if need be. So totally, it's the only reason why. All right. So now step number 3 here is state the level of significance. Now I didn't really state it here in this problem, but there is an extra line here, so let me put this here. So it will literally tell you in the problem what the level of significance is. In this case, it says specifically, it says to use alpha here, and I'm going to put in a symbol. Is there an alpha here in this case? Yes. Okay. So it says use alpha here is equal to 0.05 level of so essentially step 3 is just stating exactly what it's given to you in the problem. There's no rhyme or reason how you find this. It'll just tell you, hey, I want you to use this 0.05 level of significance. All right, so the most common ones for levels of significance, by the way, I guess I can add that here. It's really quick. Is the most common you'll see in most problems are going to be equal to 0.01, 0.05, and 0.10. So you will see one of these three in most of the problems that you're going to be encountering. All right. So most of the problems you'll be encountering will be these three levels of significance, but some problems could have different levels. Okay, maybe given, but these three are you see most often. In any case, I want you to just state it outright in step number 3. We're going to come back and use it here near the end of the problem. All right. Now, step number 4. So you'll notice a pattern here in a lot of these parts. Step number 4 here is going to be computing the test statistic. Okay, so we're going to compute the test statistic. So this is a formula here that you'll need to go ahead and write down. All right. So one of the things is that in some of the problems here on the homework, they may ask you for finding the test stat. All right. And so here is the test stat here. The test stat here is equal to x over n minus p, all divided by the square root of p times 1 minus p over n. Now, I did write this differently than the book wrote it. The book wrote it is like p minus like p0. I wrote it very differently on purpose because it's actually more confusing in the book than it is if I write it out like this of what you see here on the screen. Because you do need to use an X and you do need to use an N. It just doesn't really tell you in the book all that well. I wasn't too happy. I'm never too happy with this formula about how it's written in the textbook here. So I prefer that if you write it this way in your notes, you'll know where each part needs to go. It's a little bit more clear about how things will work. Okay, and what needs to go where. So X is going to be, say, again, the number of yeses as a sample size. P is the population proportion. And then, of course, that's going to equal the test stat here. No problem. Okay, so let's go ahead and find this test stat here. All right. We'll actually find this test stat here, but maybe not in the way you thought it would. But we'll write in the numbers here nonetheless. Honestly speaking, I'll be perfectly honest with you guys. I don't really like using the notation for test stat either. It tends to be more confusing than what's necessary. So again, I just write out test stat here so it's easier on me to know exactly what I'm trying to find here. So if you notice, it's a little bit different than what you would do, but I'm gonna go ahead and do that here right now. So let's go to our question here really fast. We go to our question here. It says again, what's our x and what's our n? We need an x and we need an n and we have a p. So let's our p here, by the way, is going to be the same 0.52 that we have from up above. Okay, so that's our population proportion here. Okay, so from our initial step here, that's what our P is. What is our X and what's our N? What is X and what is N here in this problem? What's our X and what's our N? Okay, X is 256. I agree with that. And N is 800. That's right. Good. So we have X is 256 and N is 800. So 256 people said yes to our question out of the 800 that we pulled. Fair enough. All right. So going with that here, let's go ahead and take a look here at the formula. Let's plug in the numbers where exactly they need to go. All right. So here we have, first of all, X over N. So we have 256 over 800. We're going to subtract that by P, which is 0.52. Divide that by the square root of, in this case here, 0.52 times 1 minus 0.52. And we'll divide that by 800. All right. Now, what I'm going to ask you to do next here. All right, this is going to seem a little weird. All right. But I'm going to ask you to do something a little strange here next. I'm going to ask you not to calculate this out just yet. Okay. We're going to do something simultaneous here instead. Okay. So we're actually going to go ahead and find the test stat and the next value, which is the next step in the process here, at the same time. All right. So you have this written down. That's good. That's exactly what I want here. Okay. What I also want here, though, is, again, we can find this value here. We're going to go ahead and find this at the same time as we're going to find another value that we're going to use here in this hypothesis testing. Okay? All right. So let's go to the next step here, which is going to be step number 5. Step number 5 says use the calculator. We're going to use one prop z-test to determine the p-value. Okay, so I'm going to find this quote-unquote p-value, and I'm going to find this at the same time as the test statistic here in step number 4. Okay, so I'm going to find both of those out at the same exact time here. And we're going to go over this together here about how to do that now. Okay. Okay, so we're going to use again one prop z-test and calculate it out. All right. Grab a calculator here. All right. So let's go over the calculator portion here together, and let's see exactly what we're working with here. All right, so the first thing we're going to do here is we're going to go ahead and hit the stat key here. So let's hit the stat key, and we're going to scroll over to tests. So let's scroll over to the tests menu here underneath stat. And so we have the tests here. Now we're going to go right here to number 5. So number 5 here says one prop z test. Okay, so number 5 here, one prop z test. All right. Oh, okay, so step 5 here, we'll do number 5 here, which is the one prop z test thing. All right, we're gonna go ahead and hit enter here on one prop z test. All right, and let's go ahead and take a look at what we have here. First of all, let's take a look at each part here that we see. All right. The first thing that you see here is P0. Now, P0 here is just the same thing here as P. Okay, so here, well, from the setup here in part 1, this is where we're going to plug in 0.52 here into our P0. This is what we're starting from. This is what we're going to compare. So 0.52 needs to go into the P0 part. Our population proportion will go into that slot right there. Next is our X value, and our X value here we found in step 4 was our 256. And our N value here was 800. So we're going to put those in appropriately. All right. Now, the next part here is why I actually ask you to go ahead and state the type of test. Because at this point here, you have to tell the calculator what kind of test you want to do. So this is basically what it's telling you here. It says, okay, it says not equal to P0, less than P0, bigger than P0. So not equal to P0 is a two-tailed test. Less than P0 here. So not equal to 0 is a two-tailed test. Less than P0 is a left-tailed test. Bigger than a P0 is a right-tailed test. It doesn't tell you that outright, but this is why I ask you to state it here in step 2 and why it's so important. You need to highlight the proper test here in order for it to make in order to get the proper numbers to come out. So we're going to leave this as not equal to because that is reflective of a two-tailed test. Okay? We're going to go down to calculate and let it do its thing. Okay. All right. So before we move any further, I want you to take a look at the calculator on my screen. I want to be sure that you guys got the same numbers that I did. Okay. So please type done in the chat if you got the same exact numbers that I have on my screen. I want to be sure everybody's on the same page here. Okay. Okay. Hopefully everybody's got the same thing here. Done. Okay, good. Excellent. All right. Okay. So let's take a look here at this. Okay, now that everybody's said here they're done, I'm said okay. Well, let's take a look at some of the values here. First and foremost, let's look at this very first value that says z. Well, this is our test statistic right here. So our test stat here, we can find right away is that very first number that you see there. So that's minus 11.3228. Okay, so round that to 4 decimal places. That's going to be our test stat right there that we had plugged in all those numbers in for, no problem. The next number that we see here is going to be the p-value here. All right, so let's put in the p-value here. Now, admittingly, this p-value here is pretty, well, practically 0, but find out why. So the p-value here, in this case, more importantly, is 1.0396 times, now this e to the minus 29th power, we've talked about this before. This is times 10 to the negative 29th power. So this is like 0.2801036. It's pretty much 0. So if we were to approximate this, then probably in the screen here you put 0, 0, 0. This is basically what it would be equivalent to, basically. So yeah. In any case, this p-value here is very, very small. Okay, so the p-value here, remember, is never above 1. All right, so please make sure that the p-value here is a probability value. All right, that's what the P stands for. So you should never write something that's above 1. That would be pretty bad. All right. Okay. So that's basically our p-value here and our test stat right here. Okay. So we have both of those values all set and ready to go. All right. Don't need to worry about the other two values here. We're not going to be using them here for the purposes of this problem. Just going to be using it just pretty much as normal. Okay. Let's take a gander here at next step. Okay. We're actually using such a tiny number? Yes. Yes, we are. Because we need to use the tiny number here for this last step here, Mazdi. So, irrespective of how tiny that number is, it is actually very important here to do a comparison with this number. Okay. So, essentially, the test stat here, small numbers finally getting representation. Can't argue with that. All right. So let's look at step 6 here. And this is the reason why we're going to be using this number here. And we have to make a conclusion. Now, as we stated earlier, there's only 2 conclusions that we're ever going to make. All right, there's only 2 final answers that are ever going to happen here in any of these hypothesis testing problems, okay, at any time. All right, so the way it works like this. It says if the p-value is less than the level of significance, I'm going to put a underline there. If the p-value is less than the level of significance, then we can make the conclusion that we reject the null hypothesis and accept the alternate hypothesis. Otherwise, if that's not true, we accept the null hypothesis and we reject the alternate hypothesis. Simple as that. One of those 2 conclusions has to be true. Okay, which one does it fall underneath? Well, it determines if the p-value is less than our level of significance. So the question I always write down here, specifically for how I do these problems out for step 6, I ask, and of course this is an easy question, but again, I always write this out here so that way is 1.0396 times 10 to the negative 29th power less than our level of significance, which in this case here was stated in step 3 to be 0.05. That's why I have you state the level of significance, so that way you do not forget. So this is a simple yes or no question. Is this less than the 0.05? Okay, so the answer is yes, okay? Yes, this is definitely less than 0.05 by far and away. Yes, that's right. That was a good correction. I approve. Uh, so at the end of the day, what we're going to do is, because this is yes or yes, whichever way you want to go with it, we're going to reject the null hypothesis and accept the alternate. Oh, thanks, Toaster. Um, let's see, is this working now? Okay. Toaster, by the way, my dude, my math lab is back up. I just checked it just a second ago. It's back up. They were having issues for like a half hour or so, so I think they just fixed it. So hopefully that so if you were in like in the middle and it was like not helping you, then there you go. I think Math Lab's back up there. All right, cool. I was a little worried. I'm like, oh, you didn't finish the test. I'm like, okay, cool. Homework and test is done. No problem then. You're in the clear. All right. Okay, so that's how we can finish up our hypothesis testing here for this problem. Are there any questions about that? Any questions about this example? We'll do another example here, but just it's a nice, good start here. So I'll have you guys give one a try, and then we'll work with that. Okay, seems good. All right, so far so good. Now I do want to do one more example here, and the reason why is I want to give you guys an opportunity to go ahead and give it a try on your own. So for a few minutes or so, and we'll go through it together. So I can get access to the textbook like I can. For the page here. This will be the last example here. Just but I just want you guys to have a different look. For 9. There we go. All right. All right. Let's have you guys try a specific problem here. All right. Let's see, which one do I want you to do? Okay, let's have you guys do number 26. Let's have you do 26. All right. Yeah, you guys can see that. All right. So, in an American Animal Hospital Association survey, 37% of respondents stated that they talked to their pets on the telephone. A vet found this result hard to believe, so he randomly selected 150 pet owners. Discovered that 54% of the 54 of them, so not 54%, but 54 of them spoke to their pet on the phone. Does the vet have the right to be skeptical? All right. Use a 0.05 level of significance. Okay. Okay, so let's go ahead and do that there. Let's give it a shot. We'll take a few minutes here. So we'll take 5 minutes here and have you guys give this a try. And we're gonna go through this step by step here with the steps in mind. So let's go ahead and put this over on the side here. I don't know what happened there. Okay, there. I don't know what's going on, but I'm gonna hang on a second. I'm gonna try this again. Why would we go to 545? That's not where I wanted. Here we go. I don't know why that was so hard. Okay. You know, I have seemed to be having issues. I don't even know why. Oh my gosh. Bad. I'm just gonna leave it like that. You know what? I don't even know what. All right. Technical issues, I know. I swear. I didn't know clicking something could be, Tell that to my brain, Natty. There's always technical issues up here. Like, what are you doing? I have no idea. What do I think I'm doing? I don't know. How are you teaching this class? You got me on that one. You mean they put you in charge? Like, yeah, I know. Even I'm like, what the heck? Really? Guys, man. The My Math Lab issues are spreading. I mean, I ain't gonna lie. My math lab has been kind of up and down past couple days. So yeah, I know. You have that's why look, you went to procrastination station. You had some time afterwards. So, that's just how it has to be. I'm given a couple extra days. So you can't fault me. There was times where my math lab was working just fine. You had a chance to finish it up. Okay. I think I've been more than fair. You had over 2 weeks of which to finish. So, or like, and then, yeah, literally 2 weeks. So I cannot be faulted for this one. Cannot blame me. Blame cannot come in this general direction. Oh, here we go. I found a picture. Yeah. I found a meme. There you go. Mass Frozen took the risk to refresh it. Okay. I found a good meme. Memes are dreams. If you guys don't know, I'm on Discord right here. So this is the current Discord as we stand. So I thought I took off that status. Excuses, I tell you, excuses. I'm glad most of you got it finished, though. We'll give it another couple minutes here. Hopefully you can finish up this problem. So, all right. Give about another minute, and then we'll go ahead and try this problem out together, see what you guys got. Once you guys get the process down for these problems, for this problem, it's really not. It's pretty fast. So it's not like it's terribly hard. Like you just have to follow the steps there. That's all. All right, let's give it a shot. Let's give this problem a shot. All right, ladies and gentlemen, let's do it. Okay, so hello. All right. In any case, let's go ahead and do number 26. Talking to your pets. All right, so let's go through each step here. Step 1, let's state the null and alternate hypothesis. Can anybody tell me here, what is the null hypothesis? What is the null hypothesis here in this problem? All right, 0.37, that's correct. Okay, good. So P here is equal to 0.37. All right, what is the alternate hypothesis here? What's our alternate hypothesis? So I agree, 0.37, null hypothesis, 100% true. And what's our alternate hypothesis? What do you guys think that one was? Was that less than, bigger than, or not equal to? All right, so we're going to keep the same numbers here, same stuff. And the answer here is indeed correct. That is correct, Natty. It is not equal to. Right. Again, because he is skeptical. All right, so he doesn't think that it's true, right? But he doesn't say it's less than or bigger than. He just doesn't think that that percentage is accurate in any capacity. Okay, so he doesn't think it's true. All right, fine. Whatever he wants to think, that's his claim. All right. So what type of test do we have here? Let's go to step 2. What type of test do we have? Two-tail, that's correct. We have a two-tail test. So we have to declare the test as a two-tail test. All right, fine. Seems fair. All right, we're also given a level of significance here. It says use a 0.05 level of significance. So just going to write that in. Fine. All right, so that's given to us here. Level significance, done, dusted, easy peasy. Just stated to us here. All right. So now we are given P is not equal to 0.37, fine. And we need an X and we need an N as well. So let's find that here. What is X equal to? What is N equal to according to this problem? What do we have there? X is equal to something and N is equal to something. What's that going to be? X is 54, right? And how many people did we ask? It's question 2. Okay. Okay, N is 150. Good. That's right. All right. Very nice. Nice job, Susan. And Nettie. All right. All right. So let's put our test stat into play using our formula. So our test stat here, again, is going to be equal to, we're going to have 54 over 150 minus 0.37. We'll divide that by the square root of 0.37 times 1 minus 0.37 all over sample size here, which was 50. Again, we are going to find this at the same time as our p-value. So I'm going to go ahead and go through these options. Okay. Okay, so step number 5 here is to find the p-value here. All right. All right. Did you guys find your p-value? Hopefully you'll get the same p-value that I'm about to get. So I hope you get the same p-value here. But let's go ahead and go do this together here. If you're not sure, I'm going to go ahead and hit the stat key here. Go to tests. I'm going to go down to number 5 here, one prop z test. This time, we're going to put in 0.37, 54, 150. We're going to have a two-tail test here once again, so we'll keep it as not equals. Go ahead and calculate it out. Okay. So here we get a test stat of negative 0.2537. It's okay to be negative. It's okay to get negative values for your test stat. It's just a z-score. So all right. And our p-value here is 0.7997. Okay. Okay. Good. Did you guys get the same thing that I did? I hope you did. So that's what you should have gotten here, at least for this part of the problem. Yep. Nice. All right. Good. Really happy to hear that. All right. That's really, really good. All right. So what's the last step here? What do we got to do? What do we have to do last? What's the last part? Compare, make a conclusion. Okay. So what am I comparing? Okay. I agree with that. What am I comparing here, Susan? To determine if it's less than 0.05. Okay. What's less than 0.05? You say it's, but what is it's? Okay, so right, the p-value here, right? The 0.7997. So let's answer the question here again. Is 0.7997 less than our significance level of 0.05? Is that less than 0.05? Yes or no? No. Okay. So definitely not, right? That definitely can't be true. So what's our conclusion that we can make here? Ah, there we go. Perfect. So accept the null hypothesis and reject the alternate. Very good. That is absolutely correct. Good. So actually, it's pretty accurate to say 37% of people do talk to their pets on the phone. Not a problem. All right. Okay, any questions about that? Okay. All right. All right. Well, great job, everybody. All right. Very, very nice work today. I think you guys have got a good handle on at least the beginning throes of a hypothesis testing. We'll be doing more hypothesis testing here in this chapter. We have a couple more sections to go here in chapter 10. So we're going to be doing those two guys here for next week. All right. So we're well on our way. All right. Very, very wonderful job here today, everybody. Thank you. Thank you guys very, very much for coming on out here to the stream once again today. I really appreciate your guys' time. Again, but many of you have done the test here, so that's really good. You guys have done really, really well. If you haven't done the test here yet, my math lab is working. Okay, I can confirm that for a fact. It is definitely working. It is available and waiting for you to finish up homework and tests and whatnot by tonight. All right, so please go ahead and do that there. I would highly encourage you to do so. No problemo. All right? All right. In the meantime, however, I want to thank you all very much here again. I love all of you. All of you are wonderful, wonderful people. All right? I wish you nothing but the best here. All right? Everyone, have yourself a wonderful weekend here. And as always here, I like my message. And as always here, all right, as always here, stay safe, stay healthy, and most importantly, everybody, stay sane. Everybody, have yourself a great one. We will see you on Monday. Have a wonderful weekend, everybody. Take care of yourself. All right, everybody. Have a good one. See ya. Bye.